Dear students, now I am going to explain you about point, line, line segment and plane. Before explaining, I will tell you a short incident. From that you tell me what you observe. Vani and Ronnie started playing with a few long sticks. When it was Ronnie's turn, she had to take one stick without disturbing the other sticks. She loses her game even if there is a slight shake in the other sticks. That is the condition for that game. Oh, what a great different game! Many questions arose in the mind of the third person who was observing this game. Try to answer the following questions. If you are able to answer the following questions, you will get some idea about line. All those sticks, one line segments, what can be done with these? If these line segments are arranged close to each other, how far can it be extended? Which is the longest line in the world? If a lamp post is fixed in your village, how high will it be? How far will it go piercing the sky? If it is sent piercing the earth, will it come through the other side? What do we get finally if we keep breaking the sticks? Railway tracks and electric wire above our heads do not touch each other, however, they are extended. They keep moving in a very friendly manner. Do they meet anywhere? Using line segments, tower-shaped segments can be formed. Can we form a circle? For all these questions, we get knowledge through geometry. What is geometry? Geometry is a branch of mathematics which answers such type of questions. Geometry gives the idea of various shapes and figures. We know about different kinds of lines. Some are small and some are big. Some meet each other but some do not meet each. Few lines keep extending. The length of small lines can be measured. Is there a small line without any length? If so, its length should be O centimeter. Such a line can be considered as a point. So, a line is made up of many points. We can name a line with different lengths as line segment. Which extends indefinitely on both directions are considered as lines. Which extends indefinitely in one direction is considered as a ray. Now coming to points. Point is not something new to us. You would have seen Rangoli designs being drawn using points either every day or during festival seasons such as Pongal, etc. A point indicates a definite position. A point is smaller than a tip of a pencil or a pen used by us. Therefore, point has no length, breadth, height and thickness. Points only usually denoted by capital letters such as A, B, C and so on. Now we can see about line. Observe the given figure carefully. As the space in between the points decreases, they join a form of a line. A line is a set of points closely arranged without gap. Make points AB on a sheet of paper using a scale and draw a line passing through these points. This is a straight line. It is represented as AB or line L. When we present a straight line as AB, it means the line passes through the points AB. The line extends on either side of A and B. Observe the following lines. This is called as PQ or a straight line PQ. This is a straight line L. These are all lines L1 and L2, two straight line passing through the point P. Next, we will see about ray. A ray starts from a fixed point and it extends indefinitely in the other direction. A ray is denoted as AB. That is, starting point of the ray is A. The ray passes through the points A, B. The ray extends through the point B. A ray is a straight line, a starting point and it extends indefinitely in one direction. Now we shall see about line segment. Line segment is a part of a line, that is, mark a point x, y, z on the straight line A, B. Consider AX as a part of the straight line which starts at A and ends at X. So, it has a particular length. This is called as the line segment. It can be denoted as line segment AX. Few more line segments from the above figure are AY, AB, XY, XB, YB and XZ. Therefore, line segment is a part of a line. It has a starting point and an end point. A line segment has a definite length. Then we will see about plane. Straight lines, points and rays can be represented in a sheet of a paper or on the blackboard, isn't it? Likewise, floor, wall, blackboard, cardboard and top portion of the table are few examples for a plane. Therefore, a plane is a flat surface which extends indefinitely in all directions. How many points are required to form a plane? It is enough to have 3 points that not lie on the same straight line. Points lie on the same straight line are called as collinear points. In the given figure, A, B, C, D are called collinear points. Relation between points and lines. Draw a straight line passing through the points A, B. Check whether you can draw a straight line passing through the points A, B, C. Draw a straight line passing through the points P, Q, R. You can draw a straight line passing through the 2 points A, B. Since A, B, C are not on the same straight line, a straight line cannot be drawn. A straight line can be drawn through P, Q, R as they lie on the same straight line. Therefore, P, Q, R are collinear points. So, the following statements are true. A straight line can be drawn through any 2 given points. It is not always possible to draw a straight line passing through any 3 points. But a straight line can be drawn passing through 3 collinear points. Name of the collinear points from the figure. Collinear points on the straight line AB are P, Q, R. Collinear points on the straight line CD are M, N, O. Next, we will see about parallel lines. Observe the lines given below. Line AB, PQ meet at a point X. Therefore, X is the point of intersection of these 2 straight lines. So, these lines are called intersecting lines. Lines CD, EF do not meet each other at any point. So, they are called as parallel lines. Straight line PQ or S do not meet each other at any point, but they will meet at a point. Why? Because they are non-parallel lines. Non-parallel lines intersect at a point. Lines which do not intersect each other are called parallel lines. Have you observed a railway track? The tracks do not meet each other, isn't it? This is an example for parallel lines. The 2 opposite edges of a notebook are also called as parallel lines. Next, we will see about perpendicular lines. Normally, we would have seen perpendicular pillars in buildings. We would have observed that these pillars stand perpendicular to the floor. We already know these are perpendiculars. From the figure of the 2 perpendicular lines AB and PQ can be denoted as AB perpendicular to BQ. Flag post, cell phone tower, tall buildings are all perpendicular to the floor. Next, we will see about concurrent lines. We know that 2 non-parallel lines intersect at a point. If a third line is drawn passing through the same point, these three straight lines are called concurrent lines. In the figure, lines AB, CD, EF pass through one point. Here, point P is the point of concurrency. The function of many roads is an example for point of concurrency. If we draw more than 2 diameters for a circle, all the diameters meet at the center of the circle. These are called concurrent lines. The spokes of the wooden wheel or a block cart are also called the concurrent lines. Now we shall see about angles. Mark a point O on a sheet of a paper. From O, draw two rays OA, OB as shown in the figure. In this figure, both rays start from a single point O. An angle is formed at O. Two rays OA, OB are called as arms of the angle. The common point O is called as the vertex of the angle. The angle is represented by a small curve as shown in the above figure. The figure formed by two rays with the same initial point is called as an angle. The angle shown in the figure is represented as angle AOB or angle BOA. We read it as angle AOB or angle BOA. That is, vertex of the angle is always written in the middle. Observe the adjacent figure. We know that rays are named by 2 points, one at its start and one on the remaining portion. So, OA, OB represents the same ray. Likewise, OC, OD also represents the same ray. Therefore, the angles can be represented by the following ways: angle O, angle COA, angle DOA, angle COB, angle DOB, angle AOD, angle DOA, angle BOC, angle BOD. In the figure, with O as the center, OA rotates in the anti-clockwise direction and reaches OB. The rotation made by the ray is called the measure of that angle. Now coming to right angle. Fold a piece of paper as shown in the figure and unfold it. We get two intersecting line segments, name this as AB and CD. These line segments make 4 angles at the point of intersection O. We see that the 4 angles are angle AOC, angle BOC, angle DOB and angle AOD, and they are all equal. Let us see the clock. The measure of the angle at 3 o'clock is 90 degree. Each of them is called a right angle, and right angle measures 90 degree. Now we shall see about straight angle. An angle whose measure is 180 degree is called a straight angle. Let us see the figure. Measure of the angle at 6 o'clock is 180 degree. Next we shall see about acute angle. An angle whose measure is greater than 0 but less than 90 degree is called an acute angle. We see some examples. Let us see the clock. Measure of the angle at 11:55 is an acute angle. Now we shall see about obtuse angle. Let us see the figure. An angle whose measure is greater than 90 degree and less than 180 degree is called an obtuse angle. Examples are, let us see the clock. Measure of the angle at 8 o'clock is an obtuse angle. We shall see about zero angle. Let us see the figure. If both the rays coincide, the angle formed is 0. Let us see the clock. Measure of the angle at 12 o'clock is a 0 angle. Now coming to complementary angles and supplementary angles. Do you know what is complementary angle? Let us see the figure. In the figure given, angle AOB is 90 degree. We know that it is a right angle. The other angles are, angle COB is 60 degrees. That is, 30 degree plus 60 degree is equal to 90 degree. 30 and 60 are called as complementary angles. If the sum of the measure of two angles is 90 degree, then they are called as complementary angles. For example, when a ladder is leaning on a wall, the angles made by the ladder with the floor and the wall are always complementary. The complement of 40 degree is 90 minus 40 degree is equal to 50 degree. Then the complement of 66 degree is equal to 90 degree minus 66 degree is equal to 24 degree. The complement of 35 degree is equal to 90 degree minus 35 degree is equal to 55 degree. Now let us see about supplementary angles. Let us see the figure. In the given figure, the angle formed by AB with 0 is a straight line, that is 180 degree. 130 degree and 50 degree are supplementary angles. If the sum of the measure of the two angles is 180 degree, then they are called as supplementary angles. Therefore, supplementary of 40 degree is 180 minus 40 is equal to 140 degree, and supplementary of 110 degree is equal to 180 minus 110 is equal to 70 degree. Supplementary of 66 degree is equal to 180 minus 66 is equal to 114 degree. Next, we will see about two-dimensional. Dear students, now we are going to learn about two-dimensional. It is also known as reflection symmetry, that is also known as linear symmetry. Now we will see about the definition of linear symmetry. A figure is said to be symmetrical about a line L if it is identical on either side of L, and L is known as the line of symmetry or axis of symmetry. Look at the design given here. If we hold it along the line AB, we shall find that the designs on the two sides of AB exactly coincide with each other. We say that the given figure is symmetrical about the line AB. Here are some examples for symmetry. A line segment is symmetrical about its perpendicular bisector. Let AB be a given line segment and let POQ be the perpendicular bisector of AB. Hence, the line segment AB is symmetrical about its perpendicular bisector POQ. A rectangle has two lines of symmetry, each one of which being the line joining the midpoints of opposite sides. Let ABCD be a given rectangle and let P and Q be the midpoints of AB and DC respectively. Now, if we fold the rectangle along PQ, we find that the two parts of it coincide with each other. Hence, rectangle ABCD is symmetrical about the line PQ. Similarly, if R and S be the midpoints of AD and BC respectively, then rectangle ABCD is symmetrical about the line RS. A circle is symmetrical about each of its diameter. Thus, each diameter of a circle is an axis of symmetry. Here, a number of diameters of a circle have been drawn. It is easy to see that the circle is symmetrical about each of its diameter drawn. Hence, a circle has an infinite number of lines of symmetry. Now, we shall pass on to some of the three-dimensional shapes. Dear students, now we are going to learn about some of the three-dimensional shapes like cuboid, cube, cylinder, sphere, cone, prism and pyramid. You had the idea of space. When we look at something empty like a box, room or bowl, it has a space. We can keep things in that space. A park has space for us to play. What is a solid? An object that has a fixed shape and size is called a solid. A solid occupies a fixed amount of space. Solids occur in different shapes. These shapes are known as three-dimensional shapes. The various types of these shapes are shown below. Now, we will see about cuboid. Solids such as wooden box, a matchbox, a brick, a book, an almirah, etc. are in some of these shapes are given below. Cuboid. A cuboid has length, breadth and height. Various parts of the cuboid are also given below. Faces. A cuboid has 6 rectangular faces. The opposite faces of a cuboid are identical. Edges. 2 adjacent faces of a cuboid meet in a line segment called an edge of the cuboid. A cuboid has 12 edges. Vertices. 3 edges of a cuboid meet at a point called a vertex. A cuboid has 8 vertices. Thus, a cuboid has 6 rectangular faces, 12 edges and 8 vertices. Now coming to cube. A cuboid whose length, breadth and height are equal, then it is called as a cube. Examples: ice cubes, sugar cubes, dice, etc. are all the examples of cube. Clearly, as a cube has 6 square faces, 12 edges and 8 vertices. Now we will see about cylinders. Objects such as a circular pillar, a circular pipe, a test tube, a circular storage tank, a measuring jar, a gas cylinder, a circular powder tin, etc. are in the shape of a cylinder. A cylinder has a curved lateral cylindrical surface and 2 circular faces at its ends. A cylinder has no corner or vertex. A cylinder has 2 plane faces, namely the top and the base, and 1 curved face. It has 2 circular edges. The distance between its end faces is called as its length. Now coming to sphere. An object which is in the shape of a ball is said to have the shape of a sphere. A sphere has a curved surface. A sphere has no vertex and no edge. Now coming to cone. Objects such as an ice cream cone, a conical tent, a conical vessel, a clown's cap, etc. are in the shape of a cone. A cone has a plain circular end as the base and a curved surface tapering into a point called it as vertex. Now coming to triangular prism. A solid whose lateral faces are rectangular and the base are concurrent triangles is called as a triangular prism. A triangular prism has 6 vertices, 3 rectangular lateral faces, 2 triangular bases and 9 edges. Now coming to pyramid. A pyramid is a solid whose base is a plane rectilinear figure and whose side faces are triangles having a common vertex called the vertex of the pyramid. The side faces of a pyramid are called it as lateral faces. Now coming to square pyramid. A solid whose base is a square and whose side faces are triangles having a common vertex is called a square pyramid. A square pyramid has 4 lateral triangular faces and 8 edges. Next we will see about triangular pyramid. A solid whose base is a triangle and whose side faces are triangles having a common vertex is called a triangular pyramid. A triangular pyramid has 3 triangular lateral faces, 1 triangular base and 6 edges. A triangular pyramid is also called as a tetrahedron. Okay students, in this session you all had seen line, line segment, plane, angles, 2-dimensional and 3-dimensional shapes. I hope you all had enjoyed this session. Thank you students.